Welcome to Module 4, Lesson 3. We are going over exponential functions and their graph. To prepare for this lesson, you need to be able to determine the domain and the range from a graph, be able to use and graph transformations, and have a general understanding of asymptotes. The learning objective is to evaluate exponential functions, to find the number e, graph exponential functions, which that's going to be the big part of this lesson. And then we're going to start solving some exponential equations. As a reminder, you can pause and rewind as often as you need. So this lesson is at your pace. And then you need to look at your course schedule to see when this lesson's homework is due. Now, before we get into these learning objectives, let's just kind of review really quickly our laws of the exponent or our exponent rules. So we don't need all of these for this unit, but it is a good thing to have as you go further on your math studies. When you have the same base and you're multiplying, you need to add your exponents together. So if this is x cubed times x to the 5th, that would be x to the 8th. If you have a power to a power, you multiply those. So x cubed all to the 5th is x to the 15th. If you have multiple things inside parentheses all to an exponent, and the things in parentheses are being multiplied, that's the key word there, being multiplied. For lack of better terms, you can kind of distribute that exponent to everything inside those parentheses. Again, if everything is being multiplied together in those parentheses. This is going to come into play a little bit this lesson, but anything with a base of 1 will always equal 1. So it doesn't matter if this is x or 1 squared, 1 cubed, 1 to the 4th, 1 to the 10th, 1 to the 100th. No matter how many times you multiply 1 by itself, it's only going to ever equal 1. This is the biggest one that we need going forward. When I have a to the negative s power, I can rewrite that as 1 over a to now the positive s. So when it goes from numerator to denominator, it changes the sign of that exponent. Or we could write that all as 1 over a to the now, again, the positive s power. And then any exponent with any base to the 0 power will always equal 1. Now, kind of alongside, but not really an exponent rule, we have something called exponential exponents, or sorry, radical exponents. Rational exponents, if my brain would work at all. Okay, so we have something called rational exponents. So if I have something like x to the m over n, you can rewrite it in radical form. So notice that this denominator is your index. This is the nth root. And so you'll have the nth root of x all to the m power. That was your numerator here. So numerator is your exponent, denominator is your index. So for example, if I had something like 16 to the 3/2 power, we could rewrite that as the square root of 16 cubed. So that 3 stays over here as the exponent. And then that 2 came around and became that index. If I don't see an index here, that's the same as a 2 right there since it's the square root. So now we can evaluate it. The square root of 16 is 4. And 4 cubed now is 64. Which is exactly what you get if you put this in your calculator. You can do 16, then your caret key to the 3/2 power, and we get 64. Now, not everything's always going to be able to be evaluated. We're going to have some variables in there, so we still need to know the technique whenever we are either converting rational exponents to radical form, or we'll need to go the other way as well and go from radical form to exponential or radical exponent.